All right, welcome back. Section 2-4 again. More chain rule. When will it ever end? We got a while yet. Buckle in. Sit back and relax. Enjoy the ride. Logarithmic differentiation today. So we're looking at the derivative of natural logs for the most part. I do want to talk about the properties before we get started with natural logs. Natural log of 1, remember, is 0. Natural log of e is 1 as well. If we if we take the natural log of two quantities being multiplied together, we can separate that out as the natural log of the one quantity added to the natural log of the other quantity. If I have the natural log of the quotient of two functions, I can separate that out as being the natural log of the numerator minus the natural log of the denominator. So, if we want to take the derivative of a natural log, we're going to take the derivative of the natural log of x is going to be 1 over x, and the derivative of a natural log of a quantity is going to be the derivative of that quantity divided by the quantity. So natural log of u derivative would be u prime over u, or the derivative of the function divided by the function. And that's really what we're going to focus in on today here, is that derivative of the function divided by the function. So what do we got here? Derivative f of x equals the natural log of 2x squared plus 3x minus 4. So our derivative, so if we have the natural log of a function, we're going to take the derivative of that function, 4x minus 3, that's a bad looking 3 today, divided by the original function, 2x squared plus 3x minus 4. And that gives us our answer. So that's the derivative of the natural log of 2x squared plus 3x minus 4. Here, take the natural log of e to the 2x. So, I don't know if I talked about that one. The natural log of a quantity to an exponent. We can bring that exponent to the front of the natural log, and then times the natural log of the number there, the value, quantity. So f of x equals natural log of e to the 2x. I would myself go and expand this out. So we have 2x natural log of e. I know the natural log of e is 1. We talked about that earlier. So I can really think of natural log of e to the 2x as just being the function of 2x. So my derivative is just 2. And we're done. If you want, and I don't know why you would ever want to, but if you wanted to, you could find the derivative of the quantity, derivative of e to the 2x. Remember, for e's, we take the derivative of the exponent, it comes to the front. Exponent of e doesn't change, divided by the original function, e to the 2x. So our e to the 2x's would cancel, and we're left with 2. Oh, look at that. So, does it matter to me which way you do it? Of course not. It doesn't really ever matter to me how you do it as long as you get to the right answer. So here, example 3, derivative with natural log of the quotient. So again, I would go ahead and rewrite this as the natural log of x minus 1 minus the natural log of x plus 2. I don't know where the 2x came from. X plus 2. So our derivative, f prime of x, we're going to take the derivative of the function here, x minus 1, which is 1, over x minus 1, the original function. And then natural log of x plus 2, derivative, we have 1 over x plus 2. So then our nice multiple choice answer, I guess, would be to find a common denominator. Common denominator is x minus 1 times x plus 2. So the first one's going to be an x plus 2, the second one an x minus 1. Multiply your negative through. The x's will cancel, and we'll end up with 3 over x minus 1 times x plus 2. And that's our first derivative. Example 4, f of x, e to the negative x times the natural log of x. Here we're multiplying two things together. So we got a product rule in here. So we have e to the negative x, derivative natural log of x, which is 1 over x, plus natural log of x, the second derivative of the first, which is going to be a negative e to the negative x. Remember, take the derivative of the exponent, comes to the front. The exponent of e stays the same. From here, we can go and clean this up just a little bit, I suppose. We have e to the negative x, so we'll factor out. So So we're left with a 1 over x minus the natural log of x. Again, depends on the person writing the question, multiple choice wise. They could find a common denominator, 1 minus x natural logs of x over x. They could make this negative exponent positive by taking it to the bottom. So we have 1 minus x natural logs of x over x e to the x. Which way do I prefer? If I'm making the question, I'll probably get you down to this final one because it gets you a little bit more of at algebra, pre-calculus topics there, but any of those are acceptable for an extended response question. A couple more examples. Here, again, you can take this as far as you want. This probably actually is a little more helpful with the problems that we're going to look at. Here we have the natural log of two things being multiplied together, x times the square root of x to the third minus 1. So I would go ahead and expand that out. We have the natural log of x. To that we're going to add, remember x to the third minus 1, square root is actually x to the third, I had 3 on my mind, x to the third minus 1 to the 1/2. If I have the natural log of that, the exponent comes to the front, so the natural log of x to the third minus 1. So we can go into our derivative. Derivative natural log of x is 1 over x. Here we're going to take 1/2 and multiply it by the derivative of x to the third minus 1, which is 3x squared over x to the third minus 1. Again, we could find a common denominator. We could do a lot of different things. Personally, I would just go ahead and leave it. We'll probably see it as 1 over x times 3x squared over 2 times x to the third minus 1. But realize that we could have you find a common denominator if it's multiple choice. Derivative of the natural log of cosine of the absolute value of the cosine of x. Why do we take the derivative or take the absolute value or have the absolute value in there? Remember, some values of cosine could be negative, but we can't take the natural log of a negative value. So we have to have those absolute value symbols in there. Not that it's going to matter a whole lot as we get into our answer, because we know the natural log of cosine of x. We know the derivative of cosine of x, which is negative sine of x, divided by the original function, the cosine of x. And then we can go ahead and find or clean that up. Derivative, or the sine of x over the cosine of x, well, that's just the tangent of x, isn't it? So we get the negative tangent of x as our derivative. And finally, find the equation of the tangent line of the graph of 3 plus natural log of 2x squared minus x when x equals 1. Again, I need the slope. I need my point. I know the x value of that is 1. I can find the y value, I suppose, at this point. Find f of 1. We have 3 plus the natural log of 2 minus 1. So we get the natural log of 1. Ah, isn't that nice? That's 0, isn't it? So we get the y value of 3. We can go ahead and find the slope, or the derivative, I guess, and that gives us our slope. Derivative of 3 is 0. Derivative of natural log of 2x squared minus x. We take the derivative of the function, 4x minus 1, divided by the original function, 2x squared minus x. We're going to find f prime of 1. So it looks like what? We have 4 times 1, which is 4 minus 1 gives us 3. Down the bottom, we get 2 minus 1, or 1. So we get a slope of 3. So we're going to write the equation, y minus 3, our y value minus our slope 3 times x minus 1. And that would be the equation. Again, you can manipulate that as much as you want in order to get to a multiple choice answer. We've done that in the past, so I'm not going to waste your time today. Good luck and enjoy the natural log and logarithmic differentiation.